Alright, welcome back. In our final video for Chapter 2, we're going to continue to talk about percents and the application of percents when it comes to proportions. So we're going to look at percent change. And so for percent change, our proportion for that, again, because we're talking about percents, is our percent out of 100. And is equal to, and in this case, since we're talking about change, we have just a little bit of a different way we're writing it. It's still kind of the same thing, part over whole. But our whole amount always in percent change is whatever the original amount in our problem is going to be at the bottom. So the original amount was on the bottom. And then on the top is going to go our change in the amount. Really important that you pay attention to this because it's not just going to be written in the problem. You're going to need to figure that out. And how you find change is you take whatever the new amount is and you subtract the original amount from it. And that will tell you how much it changed in the problem. So percent over 100 is equal to change over original is our proportion. And how we find that change in the amount is we do the new amount minus the original amount. All right, let's take a look at a couple of examples. So coats on sale, original price. So as we're writing our proportion, here we go. We have an original. It's $82. Sale price is $74.50. So in order to find the change in the amount, we take our new amount, $74.50, and we subtract our original amount, $82, and we're going to find out that the change in the amount is going to be $7.50, and it's negative, right? It's going down. It's a decrease. It's on sale, so it went down $7.50. So there's our change in the amount. And then, as always, percent over 100 over here. In this case, we don't know the percent. It wants to know, what is that percent change? And so we write that as our variable on that side. And then we solve. So we cross multiply. 82 times x is 82x. 100 times 750 gives us 750. We move our decimal place 2 places to the right. And then we solve, so we divide by 82 on both sides. And we get x is equal to about 9.1%. All right, so there's our percent change. It decreased, went down by 9.1%. It's on sale by 9.1%. In our second example, again, we have our proportion to start with. An original amount, the guitar was originally $295, but then the store marks it up, and so that it marks it up to $340. And so in order to find our change, we're going to do our new amount minus our original amount, and we find out that the change is $45. So they marked it up by that amount. That's how much it changed by. And then on this side we have our percent, and in this case we don't know our percent. That's our variable. What's the markup is what the question is. And then we cross multiply and we solve. So 100 times 45 is 4,500. 295 times x is 295x. Those products are equal to each other, and we need to get the variable by itself. So we divide by 295. And on this side we divide by 295. And we get x is equal to about 15.3%. So the amount that it was marked up from its original cost was 15.3% increase or a markup for that. All right, next thing we're going to look at is relative error, and really relative error is kind of the same thing. We're again talking about percent. So on this side we have whatever that percent is out of 100, or we can divide it and make it a decimal, but there's our percent out of 100. And then on this side again we have at the bottom kind of whatever that original value was. In this case, since we're talking about error, We want to know like the true value or the actual value goes on the bottom. And then on top goes, again, our change. And so how we find change is we subtract. We do the estimated value. So whatever that guess was, whatever they were off by, the kind of that estimated value, and we're going to subtract it from the actual, or we're going to subtract the actual value from it, so we can find that change, like how much were they off by, what was the relative error. And so this amount, when we subtract, that's our error amount, like that's how much they were actually off by. Okay, so let's take a look at a couple examples of this. The first one, the decorator is estimating a rectangular rug is 5 feet by 8 feet. The rug is actually 4 feet by 8 feet, and so we want to know percent error. And so again, here's our percent over 100 goes on this side, and then on the other side, we have the absolute value of our estimated amount, which was 5 feet by 8 feet, and we're going to subtract the original amount, which was 4 feet by 8 feet, or the actual amount, which is 4 feet by 8 feet. And then on the bottom goes the actual amount, 4 feet by 8 feet. Let's see. And then we can kind of solve these. So 5 times 8 is 40, 4 times 8 is 32, and then we have 32 here on the bottom. So we see that kind of our actual number, 40 minus 8 is 40 minus 32 is 8. So we have 32 on the bottom. So we have percent over 100 equals 8 over 32. And then we cross multiply. So 100 times 8 is 800. 32 times our unknown percent here is going to be 32x. And then we need to get the variable by itself. So we divide by 32 on both sides. And we get x is equal to 25. And again, we were missing the percent. So it was a 25% error. So again, we're finding the difference. What was the change? It was actually 32. They thought it was 40. That's what goes on top. That error goes on top, and then the actual amount goes on the bottom. Cross multiply and solve like we've done with all these problems. All right. When we're finding this error in the amount, here we're framing a poster that's 18.5 inches, and so that's our actual amount that we're starting with. 18.5 inches, and in this problem it tells us that the error that we could have, like it's going to measure it to the nearest half inch, and so we can have an error on either side, but the most that it's going to be off is by the nearest half inch. And so because of that, we could go above it or below it, but a half inch is our total amount of error. And so if we're trying to find both the minimum and the maximum amount, that half inch error right here has to be split into two. And so we're going to do 0.5, and we're going to divide that by 2, and that's going to tell us that it's going to be an error of 0.25 inches on either side. And so for the maximum, that means we're going to add 0.25 inches. It could be above that. And for the minimum, we're going to subtract that 0.25 inches. And so the most that we could be off on the maximum side, or the greatest it could possibly be on the maximum side, is 18.75 inches. And on the minimum side, the least it could be is 18.25 inches. And so again, it's to the nearest half inch. So the distance between the minimum and maximum is half an inch. That's the most that it can be. So if we were to go from 18.75 the max to 18.25 the minimum, half an inch is the most, which is what we've got there. All right, last example, we're combining the two. And just really quickly before we begin, it wants to know calculating the error. In this case, we're going to say to the nearest 1 inch. All right, so to the nearest 1 inch. All right, so here's what we've got. We're going to start with the actual. Let's begin there. Our actual amount, we're talking about volume, and volume is length times width times height. So the actual volume is 360 inches cubed. And then we want to know greatest possible air to the nearest inch. And so for each of these, we could go for our maximum. We could go up by half an inch. Again, we're going to divide that by 2. And so that tells us it can be half an inch on either side. And so if we change each of these dimensions by half an inch greater, we'd get 12.5 by 6.5 by 5.5. Put that in there, 5.5. All right. And when we multiply those, we would see that volume is about 446.875. For our minimum, we're going to do the same thing. We're just going to subtract half an inch from these original amounts, and so we could have 11.5, 5.5, and 4.5 when we subtract half an inch from each. And when we multiply all those together to find the volume, we get 284.625. And then for finding like the greatest air, right? That's what it asks us. What's the greatest possible air? We need to subtract, like we need to find out which of these distances is greater. And so we're going to do 360 minus 446, like we're going to subtract from here. And we're also going to do 360 minus that amount there, and I'm going to put these over here. But when we subtract those, the distance between 360 and 446 is about 86.875, and the difference between our actual amount and our minimum is 75.375. And so this right here, the greatest possible that we could have is 86.875. And so that's our change. Like that's what goes on top. We looked at this right here, this change in the amount that we wrote, like that air. That's what we just found. We just found the change in the amount, the change in the estimated value minus the actual value. And so that greatest possible change was 86.875. So now we're going to write our proportion. So we have percent over 100 is equal to that change, the greatest possible change, which was 86.875, over our actual value, which was 360. And then we start to solve. And so we cross multiply 100 times 86.875 is 8,687.5. 360 times our unknown percent gives us 360x. And then we solve for the variable. We're going to divide by 360 on both sides to get rid of that. And we find that x is equal to about 24%. So the greatest possible percent air was the question. The greatest possible percent would be about 24%.